Welcome to Summarize Science, where we explore the cutting edge of artificial intelligence. Today, we are looking at EVATok, a new framework that makes AI video generation much faster and more efficient. Standard AI video models usually treat every frame the same, wasting data on parts of a video that do not change. This paper explains that traditional tokenizers assign a fixed number of building blocks to every segment of a video. This is inefficient because a simple, static background does not need as much data as a person running or a complex scene. The researchers created a four-stage process to solve this problem. First, they trained a proxy model to test different data levels. Then, they used that data to train a router that acts like a smart manager. This router looks at an incoming video and instantly decides how much detail is needed for each part. Look at the diagrams at the bottom of the page to see this in action. In example A, you can see how the traditional method uses a huge amount of data for every block. Their system, labeled Rs, uses far fewer tokens by identifying when frames are repetitive or simple. This page shows how the router typically assigns more tokens to the very first block of a video. This provides a solid foundation for the subsequent frames to build upon, which actually improves the final quality. On the WebVid dataset, their approach achieved nearly 30% savings in token length. This means the AI can generate the same quality video while doing about a third less work. Table 3 highlights how EVATok beats previous systems like EVATok and LARP in efficiency. It shows better performance across multiple categories, including reconstruction and generation quality. They also discovered that aligning the video with semantic encoders helped the AI understand the scenes better. This prevents the blurry or flickery artifacts often seen in older AI videos. These examples from the UCF 101 dataset show how clearly the AI can reconstruct human movement. Even in complex generations like playing a violin or doing push-ups, the system remains stable. The adaptive length approach works for predicting future frames as well. One interesting takeaway is that the router does not have to be 100% perfect to be effective. Even if it is slightly off in its prediction, it still achieves massive gains over the old, uniform way of doing things. The team even tested this on still images and found that it helps there too, though the gains are most impressive in video. In summary, the researchers have found a way to stop AI from wasting its processing power on boring parts of a video. This makes it much cheaper and faster to generate high-quality visuals. In the future, this could allow us to generate high-resolution AI videos directly on our phones or laptops without needing massive servers. It is a major step toward making generative AI more practical for everyday use. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.